Hello guys, in this video I would like to explain about hypothesis, particularly in statistics, that what is mean by hypothesis, and we will just define the hypothesis and then we'll have some example from the real life and some example, some problem from the books. Usually you can see statistic can be divided into mainly two branches, that is descriptive statistics and inferential statistics. Descriptive statistic is just the description or summarization of the data, like graphs visualization, map of central tendencies, spread, position, etc. Inferential statistic is divided into two parts. One is estimation and the other is hypothesis testing. So we are just going to proceed to hypothesis testing, but before that testing, we need to know what is mean by hypothesis and how we can formulate a hypothesis from the given problem. So let's proceed to the lecture. Okay, so a hypothesis, a statistical hypothesis is a statement about the nature of the population parameter. I would say that let's suppose we are interested in the average height of the people of age 20 and above in the United States. So that's mean the population in that case is the all the people in the United States who are of age 20 and above. That is our population, and in that case the mean value as the parameter that we call normally mu, so the average height. So because of many restriction like financial restriction and time restriction, we cannot do this for all people, so we need to do some sampling from each state and then we calculate. So that is chi-estimation. I will do a separate video on this, but in fact that is our parameter. That's mean that mu, the average height of all the American people who are age 20 and above, as the parameter, and that mu, the average height, is parameter. We can have an assumption about that parameter, that mu, that the height of the American people who are age 20 and above as 5 like 5 feet and 5 inches or something like this. This can be an assumption. This can be a statement about the parameter. So this is a statement about a parameter. The other thing is you can have a claim or statement about the average CGPA of engineering student in the European countries. So you can assume, because and you should have some prior knowledge, because if you have no prior knowledge and you just assume some assumption, some statement about parameter, that can be misleading. So you assume that the CGPA of these engineering students in the Europe as 3.3. So that is the statement about the parameter. In this case, the population is all the engineering student in the European countries, and the parameter is the average CGPA of all these people. So that we call mu. And your statement about this parameter, that the average CGPA of engineering student in all European countries is 3.3, that is now your hypothesis. So these are some examples from the real life. Now to proceed to the testing, we should have a null hypothesis, and the definition is given in this slide. The null hypothesis, which we normally denoted by H naught, that is null hypothesis. The null hypothesis represents the default assumption or status quo. It states that there is no effect, no difference, or no association between variables. It is tested with the goal of finding sufficient evidence to reject it. So normally we can say, if we are talking about no difference, no association, something like this, and we suppose we have a regression equation and we have a dependent variable and independent variable. So normally we can assume that the dependent variable has no dependence on the independent variable. So this is some example from the real life, and you can say from the regression equation that coefficient of the regression, the predictor, we normally denote that by beta is equal to 0, and the alternate hypothesis, that will be no, not equal to 0. And this is the example. There is no significant contribution of sleeping horse in B student CGPA. This means that there is no significant contribution of sleeping horse in B student CGPA. And now this is alternative hypothesis. Now this is null hypothesis. The alternative hypothesis we normally denote by H1 or HA. And this hypothesis should be totally opposite to the null hypothesis. So let's define this now. Okay, now there's some problem, so let's make it small. Okay, let's define this hypothesis. There is, look at this again to the null hypothesis. There is no significant contribution of sleeping horse in B student CGPA. And the alternative hypothesis is the opposite of the null hypothesis. It suggests that there is an effect or difference or association. If sufficient evidence is found, H0 is rejected in favor of H1. So this is totally opposite to this hypothesis, and I will explain this when I will have a lecture on construction of rejection region, that why this should be totally opposite to the null hypothesis. You can see, you can just compare this statement and this statement. There is significant contribution of sleeping horse in B student CGPA. So this is totally opposite to this hypothesis, and this is true. We can do like this. Now we have some example, some problem, an example, and we will try to formulate our hypothesis. Suppose that if a signal of intensity mu is emitted from a particular star, then the value received at the observatory on Earth is a normal random variable with mean mu and standard deviation 4. In other words, the value of the signal emitted is altered by random noise, which is normally distributed with mean 0 and standard deviation 4. It is suspected that the intensity of the signal is equal to 10. Test whether this hypothesis is plausible if the same signal is independently received 20 times and the average of 20 values received is the use of 5% level of significance. So I will not talk about the testing, I will not talk about the significance level, and not talking about anything except the formulation of hypothesis. I will talk about all these things in the coming lectures. So look at this statement and look at here. It is suspected that the intensity of the signal is equal to 10. So you can formulate your hypothesis here. They claim that the intensity of the signal is equal to 10. So this means that you can write that mu, the average intensity of the signal, is equal to 10. And I already stated that H1 or HA should be totally opposite to the H0. So that's mean H1 mu is not equal to 10. So this is about the formulation, and remember that formulation of hypothesis is significant. It's very important. If you are unable to formulate the hypothesis, you cannot go proceed for testing of hypothesis. And if you formulate it in the wrong way, so that will mislead you. Now there is another problem, and now we can have some we will try to formulate the hypothesis here as well. The device that an astronomer utilizes to measure distance result in measurement that have a mean value equal to the actual distance of the object being surveyed and standard deviation of 0.5 light years. Present theory indicate that the actual distance from the Earth to the asteroid Pella is 14.4 light years. Test this hypothesis at the 5% level of significance. F6 independent measurement yielded the data. Okay, I will not talk about the testing again. Present theory indicate that the actual distance from Earth to the asteroid Pella is 14.4 light years. You can just look at this and you can formulate your hypothesis. So that means it's not mu is equal to 14.4. That is your null hypothesis, and the alternate is not equal because that should be totally opposite to this. The last problem is for you people. You just read this problem, formulate the hypothesis, and write me in the comments if you can formulate the hypothesis correctly or not. A hypothesis testing can be used anywhere in a number of fields like agriculture, engineering, medicine, climate science, and a lot of other fields. Sometimes we don't feel that we are testing the hypothesis. Like, suppose the basic example that when you are cooking something, uh, and you just when you are thinking that just to check whether the salt and the spices are okay enough and the food is cooked or not, you just check a small part of that food, and you assume that the salt is okay, the spices uh, are okay, and the food is cooked. You just take a small part and decide whether the salt is okay. If not, you put it more. And whether the spices are okay. If not, you put more. And if it is cooked, not, then you are just, keep on to say, make it for further cooking. So you are doing hypothesis testing here, but you don't know. We are doing the hypothesis testing. Similarly, you can do hypothesis testing in a number of ways and in the real life, but we don't feel that we are doing hypothesis testing. So, okay, this is, I think, this is enough for today, and see you in the next video. Ciao.